Almost. That's that bad.
Good evening.
Going out. Attend meeting the rest of the day.
Okay, good evening. Are we all able to get me?
Yes, we are.
Okay, thank you. So our lecture this evening, or our tutorial, sorry, that was the slip of the whole body. So our tutorial this evening is on water. So I'll go straight into sharing the screen so that we quickly proceed into the lecture so that we save time. Okay, so please feel free to ask. I'll briefly run through the few properties of water. Then from there, we'll go straight into answering questions so that we can all interact. We ask where we're not clear, where we need clarity, and so on. Okay, are we all able to see my screen?
Yes, we are.
Okay, thank you.
Yes.
So water, as we are seeing that in this diagram, we are seeing on this screen here. Okay. Okay. So water consists or comprises of 3 molecules. 2 molecules of hydrogen, these we are seeing in white, and 1 molecule of oxygen. So this basic chemistry, we know it from grade 12 and so on. So we'll skip the basic chemistry and we'll go to what we are interested in today. So the special property of water, or the special aspect of water, is on the hydrogen bonding. Okay, this is what determines the properties of water, or this is what gives water the unique properties. The different hydrogen bonds, or the hydrogen bond found in water, gives it its unique property. So you find the question of what property of the bonding in water gives it its or gives water the, or what characteristic of the water molecule gives it its unique properties. So it's the hydrogen bond. So we see that there's an oxygen molecule in between and 2 hydrogen atoms. Okay. So these hydrogen bonds on these slides, before we come to the terms this side. So on this slide, we see oxygen bonded to 2 hydrogens. If we go to the electron configuration of oxygen, oxygen is 2,8. Okay. When we do atomic bonding in chemistry, or those who've done atomic bonding in chemistry, realize that there is the S shell in the second. First, there's a 2,S, so there's 2 in the first orbital. Then the next orbital we're supposed to have 8, but instead of having 8, from the 8 electrons oxygen has, will remain with 6. So that 6 will be divided in 2 and 4. Okay, so in order to make sure that the second orbital is full for oxygen, we need to have 8. So that completing that number 8 comes from the 2 hydrogens that have come. So they will each donate an electron, or they'll each share an electron with water. Now, because of that force of attraction that the hydrogen will create, okay, and the oxygen will create. Now, because oxygen is the larger molecule, hydrogen is the smaller molecule. So that single electron, remember hydrogen has 1 electron and 1 proton. So that single electron will be pulled towards the water, and the proton remains on the other side. So giving it a positive charge on one side. Okay. Now, since those electrons are put towards the oxygen, oxygen gains electrons, so it will have 2 negative charges. So because of that, that's what we discussed today. So these 2 negative will attract the 2 slight positive charges of hydrogen. So hence, 1 water molecule is able to attract 4 other water molecules because of this slight charge here, and the other slight charge here. Okay. So concerning the structure of water, any questions? Any questions? Feel free to unmute your mic and ask, because when you look at these properties, we only look at them for 5 or 6 minutes, then we proceed into answering questions. So please ask if you have any queries, or if later on you have queries, feel free to take us back. Okay. So the first property of water that we'll look at is the cohesive and adhesive behavior. Then the next is water's ability to moderate temperature. Then the expansion upon freezing and water's versatility as a solvent. Okay, so water is versatile, simply means you can use it for different solvents in this case. So cohesion is when water molecules stick to each other. So like molecules, okay? So water molecule to the next water molecule. We said because of the hydrogen bond, hydrogen bonding, okay? The slight positive and slight negative charges, water will attract its fellow water molecules, okay? From what we see on the first diagram here, we see that a hydrogen will be attracted to the oxygen side, the negative there, and another hydrogen be attracted to the other oxygen side, the partial negative there. Okay, so that causes cohesion. Co means same. Adhesion, it means sticking to other molecules. If you see when you put water in a cup or a glass, water will stick to the glass. Simply means that's adhesion. It adheres to the surface of the glass. Cohesion, the fellow water molecules. Then the next is surface tension. Because these water molecules will stick together strongly because of the hydrogen bonding, okay, they create a very strong surface. It looks like a plastic, or it looks like a very a thin layer, okay. So because of that surface tension of and the process of cohesion, water molecules sticking together, we are able to see small insects, small objects will not sink in water, but they'll float, and we'll see such kind of depressions on the water if you look closely. It's because of the forces of cohesion. Okay, cohesion comes about because of hydrogen bonding. So whatever we discuss will depend on hydrogen bonding. So this is cohesion. Okay, so from the first property of adhesion and cohesion, we look at hydrogen bonding. Before we look at hydrogen bonding, any questions? Any questions? Okay. Yes, madam.
Surface tension causes. Is it that surface tension causes hydrogen bonding causes surface tension, or surface tension causes the insect to float? Which one is which?
Okay. Thank you for that question. So it's a series. What causes the surface tension is the cohesive forces of water. Water molecule to another water molecule attracts. But what causes that cohesion? It's the hydrogen bonding. So be very clear on that. What causes the cohesion is, what causes surface tension is a consequence of cohesion from this sentence we have here. Okay, so surface tension is the consequence of cohesion, and cohesion comes about because of hydrogen bonding. Okay, are we together there, madam? Is that clear?
Yes, we are clear.
Okay,
Yes,
so we
we are
proceed.
clear.
We proceed like that. Any other questions?
So
Right now, who are you? What are you? I'm a hedgehog.
yes, my question is that now I want to find out what happens when we have a low surface tension or high surface tension. What are the effects?
Okay. So from the definition of surface tension, it's a measure of how hard it is to break the surface of a liquid, isn't it? So when we have low surface tension, for example, in water, when you add soap or a detergent to water, you reduce the surface tension. So whatever you add to the water will easily seep through the surface of the water. Okay? So whatever you add to the water will easily go into the surface of the water. Now, if you have a high surface tension, simply means a liquid will not easily separate. It will be stuck together. It will be like glue. Okay, glue is very difficult to separate, but water molecules will easily separate. So high surface tension means that the liquid will be very difficult to separate. Okay, it simply means wherever one particle of the liquid goes, the rest of the liquid will be with that particle. But when we have a low surface tension, it's the opposite. It means the liquid easily separates or easily breaks. The molecules easily break. So when that insect you've seen there goes in a liquid with a low surface tension, it will easily sink. Okay. Any questions there again? On surface tension, cohesion, and the adhesion? Okay, so just another addition. Cohesive forces are what you see in as plants take up water from the ground. Okay, that's capillary pull. It's because of a thin stream. The thin stream facilitates for easy cohesion. So one of the factors which supports capillary pull is a thin stream of liquid. Okay, that's why even a capillary tube is very thin. As you move on, you see capillary tubes, they're very thin. They form a thin stream, so there's easy cohesion there. Any questions again? Any more questions? Okay, so we move to the next, temperature regulation. Now, since these water molecules, okay, the water molecules are bound to each other, okay? So one water molecule will make 2 hydrogen bonds, okay? So meaning that it will attract one water molecule be bonded to 4 other water molecules. So simply means you need energy strong enough to break these four bonds from one water molecule. So it is for that reason that water has a high specific heat capacity, meaning it requires a lot of energy to break one water molecule from the other. Okay, remember one water molecule is attached to 4 other water molecules. So in order to separate, you need a lot of strength, okay, a lot of energy. Okay, to increase the motion, and then eventually they'll separate. Okay, so any questions on high specific heat or moderation of temperature?
Can you please?
Sorry?
I'm saying, can you kindly repeat?
Okay. So the first thing I'll start with is one water molecule is bonded to 4 other water molecules. That's the first thing you need to know. Now, because it is bonded to 4 other water molecules, it is not bonded by a covalent bond, but it is bonded by a hydrogen bond. Okay, so this type of bond is a hydrogen bond, which bonds these water molecules. Okay, so from there, we see that in order for us to break these bonds, okay, the hydrogen bond is not very strong, okay, but because there are a lot of hydrogen bonds, they become stronger. They are stronger in groups, okay. So this hydrogen bond requires a lot of energy. That is why when you sweat, you have water on your skin. In order for that water to evaporate, okay, in order for that water to leave your skin, it will absorb the energy, the heat energy from your skin, thereby taking up most of the energy to separate the individual molecules. Okay, so since temperature is the average kinetic energy of the molecules, in order for us to increase the kinetic energy of this water, in order to separate this water, to evaporate this water, it will absorb the energy from its surrounding. Is that clear?
Yes, sir.
Okay, so then from there we look at expansion. Now, if we look at the high energy of water, it means the water molecules are in random motion because it is liquid, isn't it? So now, because this water is liquid, when you freeze the water or during freezing, we are slowing down the motion of the water particles. What is happening? What is happening as we are slowing down the motion? We are seeing a more stable structure, okay? Why? Because the hydrogen bonds now will stop sliding over each other. They'll stop interchanging. Because, let me refer to the first diagram. As water, are we able to see this point I'm using?
Yes.
Yes. Okay. So in liquid form, what happens is that this hydrogen bond to this oxygen is not permanent. Okay? the oxygen will not permanently bond to the same, this water molecule in the middle here will not permanently bond to the same 1, 2, 3, 4 water molecules. No, it is transient. This second it is here, the next, it is on the next set of hydrogen bonds, just like that. So it is in random motion. They keep interchanging, but they stick to hydrogen bonding. So you find that this hydrogen may bond to another hydrogen to another oxygen of another water molecule later on, another quadruplet of water molecules. So in the same way, before we freeze water, it is in random motion. So they are transient hydrogen bonds. Okay? But when we freeze this water, we slow down the motion. Eventually, when we reach the freezing point of water, when we cool the water, we slow it down. But when we reach the freezing point of water, it will form this hexagonal structure because the hydrogen bonds stop moving. When it forms that hexagonal structure, it will occupy a larger space. Look at the gaps in between the water molecules here. They are bigger than the gaps when they are liquid. So in ice, water will occupy a larger space. Okay? Now, since density is equal to mass over volume, we have increased the volume of water when we freeze it. So water will float, or ice will float on water because it has a larger volume of the same mass. Unlike when it is liquid, it will occupy a smaller volume of the same mass. Are we together on this point? Sorry, are we together on this point?
Yes.
Yes.
Okay.
Yes, sir, together.
All right. So water versatility at 7, because water is water has got different charges. Because water has got different charges, or those slight positive and slight negative charges. It simply means that water is able to attract other opposite charges. A water molecule will attract other opposite charges. Okay? So because of this, water works well as a solvent. Okay? So you find that a lot of substances will dissolve in water. Substances which will have slight charges, okay, which are slightly charged. Uncharged substances will not dissolve in water. For example, sodium chloride. Sodium chloride is made of sodium and chlorine. When you add this sodium chloride to water, the hydrogen bonds will separate the chlorine and the sodium because it is an ionic bond. When that happens, if you see this molecule of chlorine here, it is attracting the hydrogen portion of the water molecule, okay, because it is negatively charged. And the sodium being positively charged will attract the oxygen portion of the water. So the slight charge there, slight opposite charge, which will attract its opposite charge of the other molecule. Okay. So are we together on this one?
Yes, sir.
Okay. Okay, so it can also dissolve compounds which are made of non-ionic but polar molecules. Remember, it has to be polar for it to dissolve in water. If it is not polar, it will not dissolve. For example, fats. Fats are not polar, okay? Or the bond in fats is between the carbon and the hydrogen. Now, because there is no slight charge, okay? There's no slight polarity in the carbon and hydrogen bonding. We see no charge in there. So there will be no force of, the force of attraction in water will be very weak, okay? Instead, the fat will bond to its feather fat molecule, okay? Why? Because when you put it in water, the water will repel the fat molecule. So the fat molecule or fat droplets will be together. You see, when you put oil in water, the oil droplet will stick together because the water molecules are repelling the fat droplets. They are pushing them towards each other, okay? But when you add detergent to that water, you reduce the strength of the hydrogen bonds. You'll see that that detergent and water will be able to wash away the fats, okay? Why? Because there's no longer repulsion between the water and the fat molecule, okay? So in the same way, water as a solvent will attract polar molecules, okay, either ionic or non-ionic, Okay. As long as there is a charge, there is a polarity, it will be attracted in water, meaning it will dissolve in water. Which brings us to our two terms, hydrophilic and hydrophobic. Hydrophilic, substances that has affinity for water. Hydrophobic, fears water. For example, oil molecules. Okay. Any questions? Any questions?
What do you mean when you say affinity for water?
Okay, so affinity, okay, is liking. Okay, it simply means it likes water. The high affinity simply means it likes water. It easily attracts to water. A low affinity means it does not attract to water. Okay, so when we say affinity, we are talking about liking. Okay, if we say this one has got hydrophilic, if a molecule is hydrophilic, meaning it likes water. Okay, if it's hydrophobic, meaning it fears water. Just like you say phobia, you have phobia for heights, simply means you fear heights. Okay. Have I answered your question?
Yes.
Okay. Any other question?
It's just the odd. It's just the odd. Not.
Sorry, are we getting the questions? Any more questions? I'm hearing people talking. Please, let's ask the question. Okay, so we move on. Are you trying to ask a question, or it's your camera or your speaker sorry misbehaving? All right. We move on. Okay, so we're not now talking of acid, bases, and buffers. Water has that property of being an acid and a base at the same time. Because of that property of being both acidic and basic, we say it is amphoteric. Amphoteric means has both acidic and basic properties. But how does that come about? And yet we know water is neutral. Under certain conditions, okay, we see these two arrows we see in the middle here simply means it's a reversible reaction. It can go forward and backwards. That water which is neutral or which has no acid or basic charge is because the rate of forward reaction is equal to the rate of the backward reaction. So in the same way, when the rate of forward reaction, okay, we are forming more of the hydronium and the hydroxide is greater than the backward reaction, we'll see that we're going to have a charge this side. Hydroxide is negative, hydronium is positive. So the water molecule with extra proton, okay, now has an extra proton, which is the hydronium, which is a positive charge. And when it loses a proton, which is the hydrogen, to its other water molecule, it will become a hydroxide. So we are seeing both acidic and basic property of water. That is why when you add water to an acidic solution, keep adding, it neutralizes. Eventually, the acidic concentration will be zero because of that property. Okay. Any question before we look at some review questions? Any question please on the properties of water? Any questions, feel free to ask.
What are buffers?
What about buffers?
What is a buffer? Okay, so a buffer is a solution which when added, okay. Okay, so our session is going to end very soon, but because it's a continuous meeting, just kindly rejoin. Once it cuts, rejoin again. Okay, so a buffer is a solution, okay? Or before I come to the chemistry, let's look at the buffer, let's say in computer science or in computers. When you're downloading something, in order for, when you're watching a video online, what happens is, for you not to be seeing a breakage in the scenes of the video, okay, for it not to be breaking, there is somewhere where it downloads for you, it holds the movie there, then it will bring it in a bunch. You see your laptop or your phone writing buffering. In the same way, a buffer prevents a huge change in charge, okay? A huge change in acidity or alkalinity. So that's what a buffer does in chemistry. So a buffer simply means it holds or delays in simple words, okay? Yes, I heard someone wanted to say something. Was that a contribution?
I just wanted to answer the question, but it's fine.
Okay, you can still answer it in your own words. At least your fellow friends will hear your terms.
I was thinking a buffer is like a solution that is able to accept hydrogen ions and donate hydrogen ions.
Okay, so it will hold the hydrogen ions for a short period of time, isn't it?
Yeah.
Okay, so what he said is now in the chemical term. Okay. Is the question answered?
So is water a buffer?
Yes, water acts as a buffer.
Just a contribution on that. Yeah, a buffer in other way, you can say it may be a solution or molecules that reduces or increases the pH value. So you can say it's an interruption whereby, let's say for instance, if the solution as maybe is acidic or maybe it's basic, let me say basic, it will be reduced it either to it natural or to acidic. Yeah, that's what I can contribute on that.
Thank you very much. So you find that the type of buffer which we are talking about for water, it's a weak buffer. That's why you need a lot of water to reduce acidity or a lot of water to reduce alkalinity. Okay, simply means if you have a lot of negative charge, you add a lot of water to that solution with a negative charge, it will become neutral. Okay, it's a weak buffer. Okay, it is not a strong buffer. Any other question? Okay, so I've got a number of questions that I would like to share with you. So I want us to participate actively. So as I'll be sharing the questions, people will be answering them one at a time, and we'll proceed like that. Hope we have enough time, but I think we have 30 minutes to go. We can do enough. Okay. So we'll start with the first one. What kind of intramolecular chemical bond holds the hydrogen atoms together? So if someone has the answer, you can just unmute and give us the answer. So if it needs explanation, you can explain a little, just in a few seconds. Yes, I've heard someone unmute there.
Again?
The answer to the first question.
Come again with the question.
It's there on your screen. What kind of intramolecular chemical bond holds the hydrogen atoms to the oxygen? Intramolecular.
I have the answer.
Yes, please go ahead and answer.
Can I answer?
Yes, please. You are free to answer.
A Sonic 1, a big tank 0. I'm sorry, you get it on camera. Oh, you're not dead. I have no idea. Do you see me dancing?
So please.
Yes, I saw you dancing.
You have so much noise.
The answer is chemical bonding.
Okay, what? So, no, one at a time.
The answer is covalent bonding.
Yes.
Covalent bond.
Okay, covalent bond. So, please mute your microphone. Please, as you are coming to answer the questions, ensure that your microphone is on. Or you ensure that you have very little interference in your environment, because everyone wants to get your answer. So the first answer there is the intramolecular chemical bond is a covalent bond. But when we say intermolecular bond, it's between the water molecules. What bond is that? Anyone?
Hydrogen bond.
The hydrogen bond, yes. So what causes the unequal sharing of electrons? Answer to question 2. What causes the unequal sharing of electrons between hydrogen and oxygen atoms?
The answer is
right.
due to
Because oxygen is more electronegative.
So let me do this. Allow me to ensure that everyone is on mute. You only answer when you raise your hand. Is that okay?
Yeah.
Yes, at least they'll be order.
Because everyone wants to answer a question. Okay, yeah. So it's better you raise your hand, then you unmute. Then you unmute. So when I ask you to unmute, in the meantime, everyone should be on mute. Let us all mute our microphones. Okay. So answer the second question. I've sent you an mute request. Okay.
I think it's because oxygen is more electronegative than hydrogen.
Okay. So because of the difference in the level of attractiveness, isn't it? Which is the electronegativity, then we have the partial charges. Okay. So why is water a polar molecule? That's the same answer, isn't it? It's the same answer. We have
yes, it's the same answer.
Okay. So we go to the next slide. Why can
I didn't get the question for question 5.
Question 3?
For question 2.
Okay. So the answer for question 2 is because of the difference in electronegativity. Oxygen has a high electronegativity than the hydrogen. Okay. So oxygen has a high electronegativity than the hydrogen. So oxygen will attract the electrons to itself, causing the hydrogen to have partial positive charges. Now, since the oxygen has attracted the electrons to itself, it will gain 2 partial negative charges on top of its electronegativity. Okay. So because of that, it will give you the answer to question 3. Why is water a polar molecule? Because of a positive 4 and a negative 4. The positive 4 is on the hydrogen atoms. Okay, the 2 hydrogen atoms, so there are 2 positive charges. Then the negative charges are coming from the oxygen atoms. Okay. Now, before we got the next question, I want to ask a question which is not here. Since water has got 2 partial positive and 2 partial negative charges, why then don't the charges cancel each other? Since water has got 2 partial positive charges and 2 partial negative charges, why then doesn't the water cancel each other in terms of charge? The water molecule. So I'll ask you to unmute. You can answer the question.
I think it is because of the bond angle. So we have a dipole moment.
Okay. So because of the bond angle, something which you learned in your lecture, you see that the angle there is about 105 degrees, isn't it? Okay. So because of the bond angle, water will not, the 2 charges will not meet. Okay. So let's move to question 4. Why can 2 water molecules stick to each other? What kind of intermolecular? I already answered this one. Or why is water a gas? Let's answer question 5. Why should water be a gas at room temperature and not a liquid? I'm seeing same hands. Okay.
Sir.
Yes.
Is water gas at room temperature?
So no, sorry.